Example 30, a tank of 2 meter cube, chapter 6, a tank of 2 meter cube, volume contains saturated ammonia at a temperature of T equals to 40 degrees centigrade. Initially, the tank contains 50% liquid and 50% vapor by volume. 50% liquid and 50% vapor by volume. Vapor is withdrawn from the top of the tank until the temperature is 10 degrees centigrade. So it is state 1 and state 2, T 10 degrees centigrade. From a valve, the tank should be have this, maybe have this. At position 1, 50% vapor, 50% liquid. Anyway, we have to write the first law in transient form and continuity equation. For the continuity equation, we have this relation sigma m I minus m e m2 minus m1. mi equals to 0 and me m1 minus m2. For the first law, we have Q control volume plus mi U second plus W control value. Q is approximately 0, the difference between potential energy is 0, velocity is approximately negligible. Anyway, we have mi equals to 0. We have the W. So now we can simplify the relation. HE, MEHE, negligible velocities and also altitude, plus M2 as 0 and also 0. M2U2 minus M1U1 equals to 0. Let me write on the next page. M E H E M second M E equals to M1 minus M2. With simplification, that we can obtain M second H E M1U1. We should calculate M2 HE U2 M1 U1. At the state 1, we have temperature equals to 40 centigrade for table B. For the ammonia, table is B21. For B21, we should, because we have two phase, for the state 1, VF and VG. For the state 1 and VFG, this is for state 2. We have temperature 10 degrees centigrade. VF2 equals VFG2 the UF1 also can be obtained. UG and UF and UG or UFG. At first we can obtain it HE. HE is because the problem says that only vapor exit, so HE should be the average of HE at temperature 40 initial and HE at temperature 10. It is HG. From the table B21, HG at temperature 40 is plus HG at temperature 10 the average enthalpy of vapor exit. HE average. So we calculate HG. Now we can calculate M1G equals to V, which is 2 on VF VG1. And M1 for the liquid, VF1 so M1 so for the equation we know for the equation M2HE minus U2 M1HE minus U1 we calculated HE till now as M1 and U1 also is the U1 can be calculated as this relation M1 U1 equals to M U for the fluid plus M U for the vapor. We calculated these quantities before and extracted for the VF as UF1 multiply UF multiply to M1 U1 is equals to the kilojoule M1H E multiply to HE kilojoule. Now we have this relation M2HE minus U M kilojoules. So the function is M2 HE is now and is 2 joules. So we have this relation for M2. In the other case, we have M2 for relation. We have V is now 50% of the total percent. For the V second, we extracted Vf as plus x2, the quality at the position state second, multiplied to the Vfg at point 2, and also we have U, so equals to the Uf2 extracted from the table. So we have an equation that are a function of x2 let me write the equation. On M second, with simplification we can obtain a equation of x2. With solving we can obtain is the quality is so we obtain the x2 is M vapor on the total M second, or we can obtain V2 x2 M2 equals to V on the specific value kilograms, and the exit mass M1 minus M second kilogram. So we obtained the mass for the vapor in the stage 2. The note is about the calculating the quality at point 2 with the energy equation simplification. This is the end of this problem.